Hi there, I'm Chris Saxon, the SQL Wizard, and today we're going to take a look at the column update mystery. That's where I update the values in one column and, with some SQL magic, also update the values in another column. So with that in mind, let's get started. I have here a table storing information about my data sisters. I'm storing their names, dates of birth, and zodiac sign. Those of you who are familiar with horoscopes will know that your zodiac sign is determined by the day and month of your birth. So if we issue an update statement such as this, we want Sally's zodiac sign to change, in this case to Libra, because we've set the month to October. Now, you'll see I'm only updating one column, birth date. So under normal circumstances, the zodiac sign column won't change. However, in this case, it will. Now, I don't have any triggers up my sleeve. To prove this, let's look at the people table. We look at the triggers, refresh it. You can see there's no triggers defined on this. So the way it's going to update is through a bit of SQL magic. Let's take a look. Okay, here we go, ready, and we've updated it. Ta-da! I only updated the birth date column, but we can see that the zodiac sign has also changed to Libra. Now you may be wondering, how did I do that? If you want a moment to think about it, or don't want to know the answer, pause the video now. Still with us? Great! Let's take a look behind the curtain and see how it's done. Let's take a look at the columns in the table. Zodiac sign has a data default of getStarSign. Now, this is a function I've written, which takes the date of birth as a parameter and returns the corresponding zodiac sign for that month and day of birth. Now, because this is a function, it's what's called a virtual column in Oracle. And rather than storing the results of that function in the table directly, every time you query that zodiac sign column, Oracle re-executes that function. This means that if you change the definition of the function, the values returned by zodiac sign will also change when you next query it. To see how we create the table, let's have a quick look at the definition. There's my function, and we can see we've got our create table statement here, and our zodiac sign column, which is generated always as my getStarSign function. Note that the generated always part of this clause is optional. You can leave this out, provided you specify the as part, you've got a virtual column which returns the value from your function. What else do you need to be aware of when using virtual columns? Firstly, and most importantly, you've got to declare your functions as deterministic. This means that given one set of inputs, you always expect the same output. To do this, you add the deterministic keyword to your function declaration. Secondly, you can only use the columns from within one table. You can't join to another table and use the other table's columns as inputs to your function. Thirdly, you've got to use this on standard heap tables. You can't use index organized, clustered tables, or any other advanced features. And finally, you've got to be on 11G or higher. That's how virtual columns work. You may be wondering, what can I use them for? Well, basically, anywhere where you have a column whose value is determined by other columns within the same table. Let's take a look at 3 examples. Firstly, student exam grades. Based on when they took an exam and the percentage they got correct, students are often assigned a lettered grade, A, B, C, and so on. By creating a function which calculates their grade letter, we can use that as a virtual column. This means that if the grade boundaries change, all we need to do is recompile the function, rather than having to issue an update which potentially changes a large number of rows. Secondly, in many retail applications, orders and invoices have statuses assigned to their workflow. So for example, an invoice might have statuses such as paid, shipped, refunded, complete, and so on. And the value of this status is determined by other columns in the invoice table, such as the paid date, the ship date, the refunded date, etc. We can easily create a function and use that as a virtual column to ensure that the status is always correct. Finally, string formatting. You may wish to store all strings in one case, for example, upper or lower, to make case-insensitive searching easier. However, you actually want to display them in the correct case. For example, with people's names, you want to capitalize their forename and their surname. You can create a function that does this, return that, while still preserving the case on your original column. That was virtual columns. We've seen how we can use them to add a column to a table, which is based on the calculation of other columns within the same table. This ensures that the value of the virtual column stays synchronized with those other columns. Thanks for watching. I'm Chris Saxon, the SQL Wizard. Subscribe to my YouTube channel to get future updates on more SQL magic. I'll see you next time.